The uncertainty in this peak intensity value is above average, given the storm's rapid evolution. Model guidance predicts Gezani will cross Madagascar in approximately 24 hours and emerge over the Mozambique Channel within 2 days. Although the storm will weaken drastically over the mountains, the concave shape of the coastline near the storm's exit point should facilitate rapid reconsolidation of the dense wind field and re-strengthening over the channel. Aided by the low wind shear environment, model guidance indicates good agreement on this general evolution over 4 days. Over the 72 to 96-hour period, the subtropical driving ridge is expected to shift southeast of Madagascar and weaken, along with a long-wave trough impacting South Africa, causing Gezani to turn southward. This is where the models converge, largely based on Gezani's latitude. The storm's more southerly path across the channel results in a straight southward turn, as depicted by most models. However, some models, such as the GFS, HAFS, and a small group of ensembles, indicate a more northerly path, causing the long-wave trough to miss the storm. Gezani could continue westward or even turn northwestward toward Mozambique as a ridge replaces the trough over South Africa. Tropical Cyclone Gezani 2026. This is a dangerous system. Possible risks include damaging gusty winds, heavy rainfall, storm surge, rough seas, landslides, and flash flooding. Information provided by JTWC wind speeds and categorizations may differ from those reported by local meteorological agencies. Gezani is located 491 kilometers east of Antananarivo, Madagascar, and has been moving westward at 15 kilometers per hour, 8 knots, for the past 6 hours. The maximum significant wave height is 7.6 meters, 25 feet. Gezani has just over 12 hours before it reaches Madagascar's landfall, as it is guided westward by the southern subtropical ridge. Given the dense and complete inner core that has already formed, the rapid intensification already underway is likely to continue until it reaches landfall. The JTWC forecast assumes this will occur, suggesting a peak intensity of 205 km per hour, 110 knots, in 12 hours. Supported by HAFSA and several statistical rapid intensity tools, the JTWC forecast remains committed to a deflection scenario. But confidence in the lower-than-average storm track forecast in the 72 to 120-hour period is likely to persist until Gezani returns to the west of Madagascar. The JTWC track forecast is close to the multi-model consensus, tending toward a blend of the ECMWF, AIFS, and Google DeepMind ensemble mean. The JTWC intensity forecast was above the multi-model consensus for up to 12 hours, then approached the multi-model consensus for up to 2 days, and then approached the upper limit of the model intensity range after 3 days, in part because some models moved inland from Mozambique and weakened. Warning number 5. Information provided by the Joint Typhoon Warning Center, JTWC.